Welcome to August 7th LeetCode Challenge, Palindrome Partitioning 2. Given a string S, partition S, such that every substring of the partition is a palindrome. Return the minimum cuts needed to be a palindrome for the partition of strings. Okay, so we're given a string S here. We have AAB, and we want to return the minimum number of cuts needed to make a palindrome out of S. So if we were to take an S, let's say cut this here. Let's see. There, right? If we have to make one cut, it'd be right here. And that would make AA a palindrome and B itself being a palindrome. Make sense? Yeah. And then A is already a palindrome itself because one letter is a palindrome, therefore it makes 0 cuts. And then we cut in the middle between A and B. For example, 3 here, we make two palindromes. We have palindrome A and palindrome B. So that's pretty much what the premise of this problem would be. The constraint is string length of string S between 1 to 2000, and S only consists of lowercase letters only. So we just make sure we return the minimum number of cuts to make S a palindrome. So to do this, so one thing you need to know is that I believe the approach to this question is a dynamic programming type of question. So that's how I'm going to approach it. There's many other ways of solution doing it, but this is the one way I kind of understand and wrap my head around. I don't entirely understand the complete solution myself in detail, but I'm going to try to walk through it with you guys. So the first thing I want to know is if S is already a palindrome, right? If I given the input S as string and that's already a palindrome, then I don't need to return anything because it's already there needs to be 0 cut if the S is already a palindrome. So let's find that out. So if S is equal, so I can say if S is a palindrome, but there's different ways of doing it. I'm going to do S is equal to basically going in the reverse direction. So we'll be taking a slice, use a slice notation here, -1. If that's the case, return 0 because we need 0 cuts for our S being already a palindrome. Okay, next case what I do is we're gonna loop through the it to see if there is basically if S going forward and S reverse looks kind of similar. So this is another base case. So this base case where S is already a palindrome, so we make 0. And there's another base case where we have to make one cut in it, such that for this example here, if we cut A and B, that's the only condition where we have to make one cut if there's 2 letters, right? So we're gonna make that base case as well. So if I in range, so from 1 all the way to the length of S, what we want to do is loop through each index in the length of the string, and if we find that the string coming from the N, basically from the beginning all the way to I, is equal to the string come from the beginning to I in reverse, right? So this means that basically if you go from the N to the forward, that means you need to make basically one cut, right? This is saying if yeah, and S coming from the back from index I to the N, right? I to the N is equal to index from let's see, yeah, I to the N, going in reverse as well. So basically, if you go start from the beginning to the index I, is equal to basically the beginning of index I in reverse order, and going from from index I to the N and go from the beginning of the next line in reverse order. If that's equivalent to each other, and these two are the case, then we only make one cut. So return 1. Right, and that's a condition for that. And also, this is a for loop, not an if. So now we have a base case down for return 0, return 1. Next, we're gonna actually look for the algorithm to define the other cases that are not the base case. So let's develop a let's see, a dynamic program approach algorithm that's gonna keep track of our cuts in a number of cuts, the number into the worst case scenario. So basically, it makes the most amount of cuts in the entire string where there's no palindromes, for instance. So if each letter is very for instance, if we have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, then we have to make individual cuts for all of them because there's no because the only way you're gonna make palindrome is if we have one letter. So this is what we're gonna account for. So we're gonna loop through that and make a so we call it cuts, and we're gonna do a list comprehension here. So for x in the range of -1 to the going in reverse here, length of s, let's see, yep, and then end this square. So we're going to define that. So this is going to keep track of our cuts, because then we're going to return the last element of the cuts, right? Once we have everything sorted out. So we're going to loop through each element or index for index in a range of length of cuts. Right? For each element in the range cuts, length of s, we are going to define two things. So we're going to have kind of 2 pointers, I should say. So we call this 2 pointers. I'm going to call it not x, not y, a, b. Cut left and right, and these are going to be 0. So what this is for is basically these are the kind of the radius of it. How I'm going to describe that would be how would I describe that? So we have a radius of cuts basically. So we'll keep this for now. Actually, we'll call it R1 for radius 1, R2 for radius 2. Put the insert function. I'll keep that simple for now. So we have defined a. So we use I as an origin point here, and then we're gonna loop. We're gonna go through basically make cuts around the index I in terms of its radius. So every time we expand out, for instance, if we have let's see, a letter like that, right? If this is I right here, we make a cut here. Then the radius of, if you increase the radius of 1 here to 1, then it'll be cut over here, W and A will be included, right? And then we just keep on expanding out. R equals 2, R1 equals 2, they'll be here and here. Alright? So we expand this radius. So we're going to keep track of it. So R1 will be the radius on this side, R2 will be the radius on this side. And that's kind of the idea behind that. And we enlarge the radius as the palindrome if the palindrome exists. So what we're going to do next is basically do a while loop here. I'm going to search for the odd number of palindromes. So yeah, search for the odd number of palindromes. So while I minus R1 is greater or equal to 0, and I plus R1 is less than the length of s, so it has to be within our bounds. Obviously, it has to be greater than or equal to 0 because it can't have a radius smaller than 0, and it can't have a radius larger than the length of the string itself because that'll be out of the bounds of strings. And another condition would be if it's palindromic, right? So that means that s at I minus R1 has to equal s minus I plus R1. Right? That's the right side palindrome radius, I should say. Then what we're going to do is we're going to update our list right here, our cut list. Okay, and we're going to do that by just updating it. So cut at index I plus R plus 1 plus 1. So it's the index afterwards, right? Updating that. And that's going to be the update with the minimum, right? So what we want is find the minimum between the cut at index I plus R1 plus 1 or cut at I minus R1 plus 1 on the outside. So is because we want to take the minimum because we want to find the minimum number of cuts needed to make the palindrome, right? There's many number of cuts you can make to make more palindromes. So we want to find the min to make, and we also don't want replicating palindromes as well. And then we also have to increment our left radius count pointer. All right, we'll do the same thing for the right side, and not the right side, I should say, the even number of palindromes, I should say. So while let's see, I minus R2 is greater or equal to 0. Same condition as before, and I plus R1 plus 1, no, R2 plus 1, right? Because this is the odd number, even number palindrome, so you need to add 1 to there. It's less than the length of S, and it has to be palindromic, and S at I minus R2 is equal to S at I plus R2 plus 1. If those conditions are met, we're going to update cuts at I plus R2 plus 2, because even number of palindromes. And then we are going to find the minimum number of cuts needed. So it'll be cut at I plus R2 plus 2, or cut at whatever is smaller, I minus R2 plus 1. And then we want to increment our radius for number 2, plus minus equals 1. So once all this algorithm runs through, we want to return the top, basically the last number of cuts. So the last number of cut. And also I should name this called cut, not cuts. Alright. Let's run this and see what it does. Alright, accepted. Time and complexity wise, okay, if we have, so this if statement doesn't really add a lot to it. This for statement does run a big O n times, but this for loop right here runs actually a lot bigger, so this will overwhelm everything else. This is the main algorithm here. So it goes through each letter in the size of the length of string, so it'll be big O of n times you have a while loop underneath here. So the while loop also has to run, it runs in parallel with the other while loop, and it's even and odd. Let's see. So it will be big O of n squared. So while loop nested, within the for loop, and at most it will go n times. Size of length of string. So it'll be big O of n squared for that. And let's see what else I could help you guys out with. Let's see. And base complexity, it would be big O of n, because we have basically a length of negative range. We have a list comprehension here, a list of basically n length of size s amount of elements inside it as well. Alright, then that should be it. So this is yeah, there you go. That's pretty much it. Have a good nice day, guys.